Good morning, students. Today we will tackle about the organic agriculture. But before that, let me introduce to you myself. By the way, my name is Roland J. Viola, your subject teacher in this subject. Before we start our discussion, we have here our objectives. So, let me read it to you. A identifies the types of organic raw materials. B identifies the types of plant residues. C identifies the types of farmyard manure. D discusses the type of agri-industrial waste. And E defines the important things to consider in the utilization of organic raw materials. Types of organic raw materials. First is plant residues. Plant residues are chemically complex organic material that enter the soil and play an important role in maintaining soil productivity by providing source of nutrients and inputs to organic matter. They are known to affect soil physical properties, availability of soil nutrients, and soil faunal populations. Types of plant residues. Crop residues. Crop residue remaining after harvest accounts for a large proportion of the organic matter added to soil. The amount of nutrients contributed by crop residue depends on the crop and the stage at which it is incorporated. Most of the crop residues are not collected for composting and nutrient recycling, but are used as animal feed, straw or stovers, burnt or left in the field for natural decomposition. Azola and blue-green algae. Most important biofertilizer for lowland rice are Azola and blue-green algae. Azola is an aquatic fern that lives in symbiotic association with the end-fixing blue-green alga Anabaena azulae. The biomass of Azola is a good source of organic fertilizer after decomposition. Azola can be used for green manuring, which could contribute from 220 kg to 60 kg NHA per season. It is considered an efficient scavenger for K and serves as a source for K for rice crops. Some blue-green algae are Geotrichia, Euglena, Pacus, Trachelyomonas, and Nitskia have been known for their end-fixing property, particularly their role as an end sources in rice paddies. Algal fertilization incomparable to NPK fertilization as biofertilizer, VG enhances soil and fertility by excreting nitrogenous compounds into the soil while alive and the release of N-fixed compounds when it decomposes. Indigenous plants, multi-purpose tree species. The potential of organic fertilizer using indigenous plants multi-purpose tree species in the reducing mineral fertilizer inputs in lowland and upland-based farming system was observed to be effective. Many researchers have indicated that plant residues from planted fallow or pruning from hedgerow in alley cropping system can contribute significant quantities of nutrients to many crops. Green manures. Green manures are crops that are incorporated into the soil while they are still green and succulent in order to improve the soil and to supply and to the associated cash crop. If the primary reason for growing a green manure is to provide N, then types of legumes should be planted. For other reasons, green manures are good materials for compost production. The Sesbania species, Sesbania sesban, Sesbania rostrate, and Sesbania aculeate, and fixing shrubs used to improve soil organic matter and fodders are widely promoted into the humid tropics. To farmyard manure. Farmyard manure does not receive the attention it deserves as it probably ranks next to plant residues in terms of abundance in the rural areas. Storage of these animals' manures is in heaps exposed to sun, rain, and wind, which result to its substantial nutrient losses. Farmyard manure can be economically source of plant nutrients, and a valuable soil amendment to soil improved quality. Types of farmyard manure. Poultry. The most important manures in the country are broiler, litter, and egg layer manure. Because poultry excrete liquid and solid waste together, poultry manure is higher in N than manure of other farm animals. Commercial broilers are reared in houses with rice hulls or wood shaving as litter. Egg layers are reared in layered or low-rise houses. Manure drops to the ground and scraped out more often. In some operations, poultry manure contains feeder, uneaten feed, and broken eggs. A stack of manure cleaned out of this poultry house may contain materials varying in age from a weeks to months. Variation in the age of the material and the type of the amount of litter in manure result in the variation in nutrient content. Cattle and carabao. The physical and chemical properties of cow manure may also depend on the feed proportion and method of waste collection and disposal. In general, cattle dung consists of 70 to 88% moisture, 20% OM, 3% mineral matter, and both macro and micronutrients. Cows are kept in dirt floor corrals where manure and accumulated urine is periodically scrapped and stocked. In some dairy farms, cows are kept in barns that are cleaned daily. The wastewater flows into the settling basin and lodges into lagoons. When it is necessary to dredge the lagoon, the wastewater is dumped in the nearest waterway and sludge is used as soil amendment. Although carabao and cattle manure are not directly applied in the field as fertilizer, they are commonly deposited as pasture areas and others are collected and used in composting. Horse. Since there is only a small number of horses in the country, very little of horse manure is available. Horse manure is often mixed with high proportion of crop residues such as straw, rice hulls, and coir dust. Swine. In commercial swine farm, manures are swept and collected before flushing them with that flows in lagoons, rivers, or nearby vacant lots. The collected manure is either dried or a drying bed or placed into the pit. This drying bed is exposed to the types of weather. However, another way of cleaning the farm is to flush the pig pen with high volume of water that flows into the lagoon. Goat and sheep. The presence of medium or large herd of goats or sheep is rare in the country. The manure from sheep and goat is particularly helpful in quick decomposition of organic residues because of their small size and large surface area. The microbial activity is enhanced, resulting in quick breakdown of residues into energy-rich nutrients. The nitrogen content is almost 2.8%. Third is animal residues. Some animal residues can be also good sources of nutrients. Animal blood, horned feet, and feathers are high in nitrogen. Oyster shells and egg rust have high calcium, compared with bulk organic material like farmyard manure and crop residues. Concentrated animal residues have high concentrated of nutrients because they contain only a small amount of organic carbon. These residues behave similarly with synthetic fertilizer when incorporated into the soil, particularly in terms of nutrient release rates. Unlike synthetic fertilizer, however, they contain at least trace amount of most of the plant nutrients in addition to N, P, and K. Agri-industrial waste. Type of agri-industrial waste. So, sugar waste and byproducts. Bagasse. Many sugarcane processing factories produce substantial quantities of organic byproducts such as bagasse, peat, and mud frost. Sugarcane has been one of the most important agricultural crops in the country for several decades and produces million tons of bagasse per year as by a product of sugar production. Bagasse is a solid waste produced after extracting the juice from the sugarcane stalks. Bagasse has high C proper and ratio and percentage of acid detergent fiber, but low crude protein and total digestible nutrients. Nonetheless, it has served as good soil conditioner when plowed back into the soil. Much of the bagasse is used as fuel. The bagasse ash contains 0.28 and 0.84 P and 2 to 5% K. Mud press filter cake. About 6% of millable cane produces filter cake or mud press. This material is dark brown to black and is composed of varying proportions of sand, soil, bagasillo, sugar, flocculants, and coagulated colloids and sediments, which included phosphate, lime, and albuminoids. The typical composition of mud press as is follow. Oil and wax lipids, so 5 to 15%, fiber 15 to 30%, sugar 5 to 5%, crude protein 5 to 15%, total ash 9 to 20%, moisture content is 65 to 80%. Acevedo Ramos determined the organic matter of mud press as ranging from 20 to 30%. Mud press contains high amounts of cellulose and hemicellulose and harbor pathogenic organisms that are spore formers and heat resistant. Hence, the raw material must be composted completely before using on crops. Sugar cane slop. This is spent washed in the production of alcohol from sugar. It contains organic and inorganic substances consisting of potassium and calcium sulfates and phosphate, traces of iron, magnesium, and sodium, proteins, gums, caramel, organic acid, glycerol, and unfermentable sugar. B. Rice hull and coir dust. The rice hull generated from all the rice mills nationwide probably amount to more than 2 million tea per year. It has very high silica content, but the other nutrients are less than 1%. The cyprian ratio is 91, thus very low, slow to decompose. It is generally used as bedding in poultry houses. It could be useful as an absorbent of excess moisture in composting municipal waste. Smoke or carbonized hull is better than ordinary rice hull. It provides a bacteria and fungus-free material and has a consistency that can hold onto water and supply nutrients of crops. Carbonized rice hull could be an important component of organic fertilizer. Coir dust. Coir is a fibrous material that constitutes the thick mesocarp middle layer of coconut fruits, Cocos nocifera. The long fibers of coir are extracted from the coconut husk and utilized in the manure manufacture of brushes, automobile seat and mattress stuffing, drainage pipe filters, twine, and other products. The short fibers, 2 mm or less, and dust pitch left behind accumulate as waste product. The high lining and cellulose content of the pitch prevents the pulp from further decomposition. It acts as excellent mulch in young plantation and conserves moisture during the dry months. It has the capacity to absorb moisture many times over its weight and is used in composting and nursery preparation. Next is the other agri-industrial waste. So other agri-industrial waste such as fruit and vegetable processing, cotton ginneries or mills, breweries, and distilleries also produce large quantity of organic waste materials which need to be properly managed and utilized for nutrients recycling instead of dumping and polluting the environment. Lumabang mill and castor bean meal are the residues after oil extraction from lumbang and castor plants. The materials contain 6 to 7% of N, and the production of the food seasoning monosodium glutamate produces a liquid waste in high and 5% considerable concentration of B 0.4% and K is 1.7%. So the material is strongly acidic with high chloride content. Nevertheless, it can be used as nitrogen enriching raw materials in composting In beer making, used hops and sludge are produced. The used hops contains 2.5 to 3.5% of it and 1% of P. The municipal biodegradable waste. The production and disposal of municipal solid waste in many countries, including the Philippines, has become an increasingly difficult problem. Currently, about 50% of urban trashes are biodegradable organic materials, which can be degraded and processed appropriately as bioorganic fertilizer. Types of biodegradable waste. Biodegradable municipal waste composes food waste, garden waste, paper and cardboard, textile, wood, and other miscellaneous biodegradable waste. Household waste. Shredding branches is often a major problem for homeowners. Many municipalities collect these woody yard waste and dump them in landfill. These wastes are potential composting material. Wet garbage. Kitchen waste such as leftover food, fruits, and vegetable peelings, fish waste. Dry garbage, paper, cartoons, junk mails, newspaper, shoes, boxes, or etc. Garden waste, plants, dried leaves, tree branches, or used clothing, shoes. Municipal waste is the wet garbage, solid fruit and vegetable waste from the market, solid biodegradable waste from the slaughterhouse. Dry garbage, packing waste, carton, wooden crates from market, biodegradable packaging materials from commercial establishment. Important things to consider in the utilization of organic raw materials is most of the nutrients concentration content in organic raw materials reported are not readily available for plant growth. Nutrients in organic material must be released by soil microorganisms through mineralization. The biological process is affected by variation in plant resources quality, moisture, temperature, and the microbial species and population present in the soil. Therefore, organic raw materials are less predictable in nutrients composition, nutrient release, and nutrients use efficacy than inorganic fertilizer. The composition and quality of organic materials are highly variable. Therefore, if organic materials will be used as fertilizer, it is important to get accurate information about its nutrients composition. To have accurate records on nutrients input, each load of material applied to the soil should be analyzed separately in analytical soil testing laboratories. Utilization of raw organic materials are usually more expensive per unit nutrient. To collect, purchase, transport, store, and apply than organic fertilizer. When evaluating the costs and benefits of various materials, however, consider the two additional benefits in utilizing organic material. First, the organic materials can supply organic matter, which improves soil physical and chemical properties. Second, organic materials provide energy for microorganisms, thereby promoting nutrient cycling within the production system and, in some cases, suppressing harmful pathogens. It is therefore difficult to assign a peso value to these non-nutrients benefits. So I think that's all for this today's discussion. Thank you for listening and God bless.